So all morning we've been talking about the ground truthing. We've been talking about some of the overarching details on how you fit the pieces together, but we haven't really talked very much about how does this workflow, or at what point in the workflow do we actually decide what land cover classes are actually being mapped? And the classifier that we're using to actually do, the main bulk of the work that we're using, the main bulk of the work that we're doing, is kind of the final component that you really need to get this whole thing together. So what I mean by classifier is just basically a tool or an algorithm or whatever term you want to use that learns what various different types of land cover classes look like. The way that it learns what these different land cover types look like is basically it goes to the ground truthing point again. Ground truthing again. It goes to your ground truthing points. It takes a look at what the imagery is like at each point that you've named water or you've named grass, and it finds out kind of the distinctive characteristics of the imagery at each of these points. And the whole purpose behind kind of developing an understanding of what grass looks like in the imagery versus what water looks like in the imagery, or ice, is so that when you are trying to map areas that you don't have ground truthing, that the classifier can just take a look at its list. It's like, oh, I've got this pixel and it's got a lot of NIR and it doesn't have very much blue. And then it's like, oh, that's a plant. And then it can keep looking like, okay, what kind of plant is it? And it can decide which one it looks most like. The difference between most classifiers is, the true, defining difference between one type of classifier versus another that you usually hear people talking about is exactly how it decides what one type of class looks like versus another one, and how it says, oh, this is grass, this is something else. It's that choice that is the real difference between classifiers. So earlier on, and actually Guar kind of already opened the discussion on this a little while ago, but classifiers are pretty much split into two camps, and one is supervised classification and the other is unsupervised. So with unsupervised classification, you pretty much free rein, let the program, let the tool algorithm do its thing. You mostly leave it alone. Often you will say, I think there are 11 different types of classes, in this mapping area, but you will not give it ground truthing, for example. You're just going to say, if I broke this map, this chunk of imagery up into 11 different sections or types, what would it look like? Instead, and the algorithm will come back and it'll give you a map. Say, well, it will look something like this, and it will have split up all the imagery into 11 different classes. Supervised classification is a bit more hands-on. That is supervised classification, as you can kind of guess your name, requires a lot more babysitting, I guess you could say, on the part of the user. So you will be telling it which classes you want to map, not just the number, but which actual classes you want to map. So you're saying, I want to map where there is tussock, I want to map where there is bare earth, I want to map where there's white grass, I want to map where there's kelp, and you list all the things that you want to be able to see, and then you give examples in your ground truthing. You can't, in supervised classification, you can't map a class that you don't have ground truthing for. And usually, as you're going through this checklist for supervised classification, you'll find that typically, but not always, you have to more dials to turn, I guess you could say, for the supervised classification than the unsupervised. But I don't want to give the impression that unsupervised classification doesn't have its worth. Guar mentioned that the segmentation, just drawing shapes from the imagery, is similar to unsupervised classification. But what's not, and in many respects it is, but what's nice is, the fact that you're a little bit more, you're letting the computer, letting the program kind of take control a little bit, is that you're less likely to bias what the results are. You may be a little bit less likely to accidentally try and overcomplicate or underrepresent, the classes in your map. So I know a lot of people who swear that supervised classification is the way to go. And like, why would you even think about unsupervised classification? You're letting the algorithm take the lead, and who knows if it's going to get it right. But flip side of the coin, there are a lot of other professors at my university that would say that letting at least running an unsupervised classification first, and kind of getting a sense of how a classifier algorithm sees or views your imagery is actually going to let you understand, what your imagery is actually capable of, the level of detail your imagery is actually capable of mapping at. You can begin to see like the features that you might not notice as a human, but the algorithm will. So if you didn't notice that the glint on the water or something like that is an important feature in the imagery as far as the classifier is concerned, and you went on your way and doing more work, until you got to the end of the process, you might not realize that there were a bunch of artifacts in the water. But if you ran a really fast unsupervised classifier first just to see what it was like, you're probably going to see like, oh, it thinks there's all sorts of weird stuff going on in the water. I should pay attention to that. So anyway, there's something to consider if you guys are working on, you're early on working on your classification. You might try just doing a quick unsupervised. It's usually really easy, usually really fast, gives you a better sense of your data. You can decide if you want to go further with it or not, but it's worth trying before you continue on with supervised. That being said, we did spend most of our time doing supervised classification for both the broad scale and the fine scale maps. So I'm going to go on to describe a little bit more of like how we worked our way through the supervised classification. But just don't forget the unsupervised. It feels lonely. People always it's not very nice, but people do. So, oh, sorry, I kind of already forgot I had the slide. So basically, yeah, supervised, not always the case, but usually, like I said, you have a little bit more control over it, over the details of how it's run. Not necessarily, but usually. The unsupervised, at least in my experience, it's often quicker. The processing finishes faster. I think it gives you some insight to just see how the algorithm sees the imagery. To go ahead and run, and it may be less biased than the supervised classification. Okay, but like I said, turning to the supervised now, since we did spend most of our time doing supervised for this project. As far as the classifier is concerned, it is taking a series. Let's just say that you have, like say you went out, took a bunch of ground truthing points not too far from Stanley, and you have this brand new nice GeoJSON that PB made for you. And now what you want to do is to use this information in your workflow to get to this final map where you actually have, your imagery sorted into line cover classes. So first, you have to be able to take the characteristics of the imagery at each of these sites, put it together in an organized fashion so that the actual classifier can decide what the characteristics in the imagery are at all these ground truthing points. And the whole reason that you're going through and you're building this library of known points, like, I know exactly what each band is doing at this point right here that I know is grass or something like that, is because even after you've compiled this big long list of all these known points, you don't know what's going on all these other points. So what you have to do is take your best guess based on the known characteristics, sort them, and then for each spot that you're looking on the map, whether it's a point or whether it's an object like we talked about earlier, you need to figure out which classification, the basic imagery characteristics at this unknown site best falls into. And that actual classifier it's basically the classifier is making the decision of whether you're going to call each point grass, going to call it water, going to call it whatever. And that way it's basically automating the process of figuring out all these other points outside of the classifier, the ground truth thing that you know, to get from image over here to estimated land cover type. So the classifier that we used most often, I shouldn't say most often, the classifier that we used for the most maps in this project so far was the random forest classifier. It might be kind of one of those familiar sounding words that you guys hear around because it's a pretty popular supervised classifier. Primarily because it's easy to run. And I've heard it both ways. Some people I've heard say, oh, it's great when you don't have a ton of, you don't have a huge ground truthing data set. And I've heard other people say that it's terrible when you don't. I'm not really sure anymore. But it seems to work okay for what we've been doing. I don't know if you guys, for those of you who are familiar with decision trees, you can think of it sort of as a flow chart, but basically the classifier is organizing the characteristics of the imagery into sort of, I guess they usually describe as a tree. So, does this particular pixel have this characteristic? Yes, no. Does it have this characteristic? Yes, no. And it makes a series of these trees. And that's where the forest comes in, because you get a whole bunch of trees describing your imagery. So you've gone from tree to forest, just trying to describe everything you've got going on. But the random component is essentially the decision of how the trees are constructed. So you're not going through as a person and saying, I'm going to check all these different characteristics and see what the imagery is like. It's done for you, which is part of why people like it, because it takes all the work out, much of the work out of your hands. And essentially, in the end, after all these randomly configured trees have been constructed, the way that the classifier decides which trees are going to be used in the final classification is basically a process called upvoting. So basically, it finds the trees that most successfully predict the ground truth classification. The classification at your ground truthing points. And so basically the trees that do the best job of describing what the recorded classification type is at your ground truthing sites are the ones that the classifier says, yes, this is reliable, I'm going to use it for the rest of the map. Yes. So we did use other classifiers, but random forest was the one that we used. The ins and outs of exactly how a lot of other unsupervised classifiers operate varies from algorithm to algorithm, but basically somehow or another it's just having to make a choice of, I've got this imagery, I've got to figure out what class it falls into, and it's that decision. Just remember it's that decision of how it decides, what class the imagery ultimately falls into. That process is what varies between different supervised classifiers. That's the main thing you really need to know. And so let's say that you've gone through this whole big long process, and you finally, after you get the whole thing done, you actually get to see a map. Like, yay, I've got a map. Something finally, it's real. So, okay. you get to this point, but then you realize you're actually not quite done, because even though you've got this beautiful looking map, you don't know for sure how valid that map is. It might just be a pretty picture for all you know, or it could be doing a pretty good job of describing what things are actually like on the ground. But you need to go back and you need to check your work, essentially. So there are a lot of different ways of doing it. The way that we've been doing the lion's share of our work for this process in this project, beyond like asking someone who lives here, like, is that grass growing there? Or whatever, you know. The way that we've been doing this a bit more quantitatively is to go through and to use to create something that's called a confusion matrix, which I don't know why they decided to name it that. That just seems like bad juju to name it the confusion matrix, but they did. And so essentially what you're doing is you're taking you're going back to your ground truthing. And I'm sorry, I should have gone into this earlier, and I forgot as I steamed through. And this is another thing that Gua brought up before I did, thankfully, so she's on it. Before you go through and you run your maps, you split your input ground truthing, all your ground truthing data set. You take a certain chunk, a subset of your points away from that ground truthing data set, and you just pull them out of the process altogether, put them to the side, and you only run the map using this larger subset of points. Usually the way that you break up whether your points fall into this ground truthing training data set or your validation data set you put to the side is just randomly assigning a number and then splitting it. But you create the map using this bigger subset, but you keep those other points that you put in the validation data set aside until you get to this point. The reason why is you want to get to the end, you want to have your map that you've created, and then you want to be able to check that it's reasonably accurate, but you don't want to check this accuracy using information that was used to create the map, because it's going to artificially inflate the accuracy of the map. Because of course, like right around the spot where you have ground truthing, it's probably going to be better because you have information there. So to be more fair, you have to test the map using data you separated out early on that didn't have anything to do with how the map was created. It's just one more step to make sure that you're actually being a little bit more careful with how you check the map accuracy. So anyway, when you're creating these confusion matrices, or error matrices is another common name for them. I just made up a simple fake error matrices here. But what you'll do is you'll arrange for each class. Let's say there are only 3 classes in this map. You have water, grass, and heath. So for each class, you'll record the actual number of ground truth water points, and then you'll take the what was predicted, the classification that was predicted at the map for each of those points, and you will check. So like in reality, in your actual ground truthing data set, let's say that right here, there were, for grasses, actually 21 points, but on your map they were predicted as water. The place that you want to be, of course, is you actually had grasses and you predicted grasses, so you want to be on this green diagonal. So hopefully when you're going through all this, you'll go, well, I actually had water and I predicted in my map that there was water, but sometimes you're going to go the wrong direction. So the confusion matrices is just a way to lay out, like, I thought it was this, but in reality it was that. And it just helps you kind of see where, you begin to see some trends like, oh gosh, for some reason, a whole bunch of my, places my map said there was water. In reality it was grass. Actually, that's not, I don't know why I put that number there. I should have checked what they looked like, but basically, I thought it was this, and it was actually that, and it just helps you start to see if you have some classes that are consistently inconsistent. And once you've gotten past this point, let's say you've got your map, you've taken a look at it, you've run your confusion matrices, and you're kind of now at a point where you're needing to make some choices and to do some thinking about, the end product of your workflow. Let's say that you're having a lot of trouble where, certain classes were being misclassified. At this point, this is where you're going to have to kind of step back and to think about kind of some of the sources that might be the sources of the problem leading to the misclassification. So this feeds right back into kind of some of the reoccurring themes that we've been talking about during the last 2 days. You're going to want to make sure, now that you have your final map and you've seen what the accuracies are, if your imagery and your field data, your ground truthing, now that you've seen the results, are you sure that what you've got is capable of producing a map that you envisioned in your mind? You can now begin to determine whether some of the classes that you thought you were going to be able to map, maybe you're currently unable to, that you're going to have to go back and decide if you need more ground truthing, if you need different imagery, if you need to use a different classifier. But this is once you get through the first iteration, this is when you need to start asking those questions. And once you've kind of taken tally and figured out where you're at, that's when you need to decide what you're going to do next. So more ground truthing is kind of a knee-jerk reaction, like, oh, I just need more field data. I mean, a lot of times you have to see if that works out or not. You might, again, look at your imagery sources, decide if you need more maps, who knows. But it's just, it's sort of a point when you get to that end where you need to kind of take that breather. So actually, I think that we're finishing a bit early for lunch.